Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be looking at stoichiometry, and under this topic, we'll be looking at the definition of stoichiometry, what stoichiometry is all about, and we'll be also be looking at the mole concept and mole relationship with other elements. So please, before you watch this video, like this video, hit the subscribe button and turn on the notification bell so you won't miss any lesson or any updates from Tech and EduSpark Hub. And stick with me till the end and let's enjoy the best out of the lesson. So what do we understand by stoichiometry? As displayed on the screen, by definition, stoichiometry is defined as the branch of chemistry that deals with the quantitative relationship between reactants and products in a chemical reaction. So this is a simple definition of stoichiometry. It is the branch of chemistry that deals with what? The quantitative relationship between reactants and products in a chemical equation. So stoichiometry helps us to calculate the amount of reactants needed and the amount of products formed. And it also helps us to calculate the mass relationship, the mole relationship, and the gas volume. So all stoichiometry calculations are based on mole concept. And what do we understand by the mole concept? So the mole concept is the amount of substance that contains the Avogadro's number of particles. So let me just put that down on the board. So this is a simple definition of the mole concept. The mole concept is the amount of substance that contains the Avogadro's numbers of particles. So we can say the mole concept mathematically we have Na to be equal to 6.02 times 10 raised to power 23. So this is the mole concept. So we can now say 1 mole of any substance is equal to 6.02 times 10 raised to power 23. So this is what the mole concept is telling us about. So the mole concept is telling us about that 1 mole of any substance is equal to what? 6.02 times 10 raised to power 23 molecules. So let's look at the important stoichiometry relationships. So let me write that down. We have the important stoichiometry relationships. So the important stoichiometry relationship is important whenever you want to solve any questions under stoichiometry. And we have 5 major important stoichiometry relationships. So let me just list that down and you can write that down as well. So these are the most important stoichiometry relationships. We have the first one, which is the mole to mass relationship. Also, we have the second, which is the mole to number of particles relationship, which is also the same thing as mole to Avogadro relationship. And the third one, we have mole to gas volume relationship. And also the fourth one, we have mole to concentration or solution relationship. And lastly, we have mole ratio in chemical equation. So let's look at all these one by one and solve example under all of this. So moving to the first stoichiometry relationship, we have the mole to mass relationship. So under this mole to mass relationship, we have a common formula, which is what? Which is mole equal to mass over molar mass. So which is denoted as N equals to M small m over big M, where the N is the number of mole in mole, so that is the unit, while the M is equal to the mass in gram, and lastly we have the big M, which is equal to the molar mass in gram per mole. So these are the units of the first stoichiometry relationship, which is the mole to mass relationship, which is given as mole equals to mass over molar mass. So let's look at examples under this for stoichiometry relationship. So the first question as written on the board says that find the number of mole in 44 gram of CO2. So in solving this kind of question, let's write our parameter. So the mass is equal to 44 gram, and also we have to find the number of moles. So the number of moles, which is n, let me just write that in full, is equal to unknown. And also, in order to find the number of mole, we need two parameters, which is the mass and what? The molar mass. So the molar mass in this case, so the molar mass of CO2, which is the compound we are trying to work with, because the question is asking us to find the number of mole of 44 gram in what? In CO2. So finding the molar mass of CO2, we know that carbon is 12, so we have 12 plus oxygen, which is 16. So we have 16 multiplied by, so this 2, it will be multiplied by 2, and our molar mass will be equal to, so 12 plus 32, which will be equal to 44 gram per mole. So this is given as our molar mass. So back to our formula, we know that mole equals to what? Mass over molar mass. And we have been given our mass to be 44 grams. So we have 44 grams divided by, what is our molar mass? Our molar mass that we calculated is what? 44 grams per mole. So we have 44 grams per mole. So in this kind of question, 44 divided by 44 will give us what? 1. So 1 mole is our final answer to this kind of question. So this is how we solve question under mole to mass relationship. So just master this formula very well, because no matter the question, you will need this formula. So master this formula very well. So our final answer to this kind of question is 1 mole. So let's look at another example, still on the stoichiometry of mole to mass relationship. And moving to the next question, the question says, what mass of NaCl is present in 2 moles? So in this kind of question, one thing about chemistry is just that you have to read the question very well. So the question is asking us that what mass? So that means you have to calculate what? The mass. So what mass of NaCl is present in what? In 2 moles. So let's write the given parameters. So in this question, we have been given our moles to be equal to 2 mole, and we have to calculate the mass. So the what mass is what we have to calculate. So our mass is equal to unknown. And lastly, we need the molar mass. So the molar mass of the compound given of NaCl is given as, what is sodium? Sodium is 23 plus chlorine, which is 35.5, is given as what? 58.5 gram per mole. So this is our molar mass. So our molar mass is 58.5 gram per mole. And from our formula, we know that mole is equal to mass over molar mass. So in solving this kind of question, we can just input our parameters. What is our mole? Our mole is 2, so we have 2 equal to our mass. We don't know our mass. That is what we have to calculate. So we have mass divided by our molar mass. What is our molar mass? Our molar mass is 58.5, so we have 58.5. So in this kind of question, to get our mass, we have to cross multiply. So when we cross multiply, we have our mass to be equal to 2 multiplied by 58.5. So our mass will be equal to, so when you multiply this, you get 117 gram. So our mass is equal to 117 gram, and this is correct to question of this type. So you can see how we solve this question. You can see it is very simple. All you just have to do is to put your mind and substitute for the parameters you were given. So let's look at the last example on the mole to mass relationship. And moving to the last example as displayed on the screen, the question says, what mass of oxygen is present in 3 moles of O2? So from this question, you can see we have been given the molar mass of oxygen to be 32 gram per mole. So we can just write our parameters. So we have been given our mole from the question. Our mole is equal to 3 moles. So the question is asking us what mass, which means we are asked to calculate the mass. So the mass is what we don't know, which is unknown. So this is what we are asked to calculate. And the molar mass given from the question, molar mass of O2 is equal to 32 gram per mole. So this is the molar mass of O2 given. So in order to solve this question, remember our formula, which is given as mole is equal to mass over molar mass. So in substituting our parameters, we know that our mole is 3. So we have 3 to be equal to, what is our mass? Our mass is what we are asked to calculate this question. So we have mass divided by our molar mass. What is our molar mass? So from the question, our molar mass is given as what? 32 gram per mole. So when you cross multiply, you will have our mass to be equal to 3 multiplied by 32. So our mass will be given as 96 gram. So 96 gram is correct to this kind of question, and from the question that we have on the screen, option C is correct to this kind of question. So this is how you solve questions under mole to mass relationship. So let's move to the second stoichiometry relationship, which is the mole to number of particles. And moving to the second stoichiometry relationship, we have mole to number of particles, which is also the same as mole to Avogadro's relationship. So all you have to note about this is that 1 mole of anything is equal to 6.02 times 10 raised to power 23. So this is all you have to note about the mole to Avogadro's relationship. Just know that 1 mole of anything is equal to what? 6.02 times 10 raised to power 23. So let's look at examples under this mole to Avogadro's relationship. And looking at the first example as written on the board, we have the question saying how many molecules are in 2 moles of water. So in order to solve this kind of question, one thing that you just have to note is that we said that 1 mole of anything is equal to what? 6.02 times 10 raised to power 23. So we can just write that first. So we have 1 mole of, so instead of writing anything, you just have to put water because we are working with water in this question. So we can say 1 mole of water is equal to 6.02 times 10 raised to power 23. So now that we have written this, the next thing to do is to look at the question. The question is asking us how many molecules are present in what? 2 moles of water. So we are given the second mole. So we can say 2 moles of water is equal to what? We don't know the molecule that is present, so we can put X in this case because we don't know the molecule that is present in what? 2 moles of water, which is what the question asks us to calculate. So in order to get this, we can just cross multiply. So when we cross multiply, we have X multiplied by 1 to be equal to 2 multiplied by 6.02 times 10 raised to power 23. So when you multiply this, you have our X to be equal to what? 1.204 times 10 raised to power 24. So when you multiply this, this is what you are going to get. So this is our final answer to question of this type. So we can just say 2 moles of water is equal to 1.204 times 10 raised to power 24. So you can see this is very easy to solve once you understand what you are doing in the question. And the reason why I ask us to write a full expression is because if we write 1 mole of anything, we won't know what we are doing, so we'll just be cramming. But when you flex and know what you are doing, you can just easily write 1 mole of water because you are working with water is equal to 6.02 times 10 raised to power 23. And you now have 2 moles of water to be equal to unknown. So when you cross multiply, you get your final answer. And you can now rewrite your expression as 2 moles of water equals to what? 1.204 times 10 raised to power 24. And this is how you solve questions under the mole to Avogadro's relationship. So let's look at the last example on mole to Avogadro's relationship. And moving to the last example as displayed on the screen, the question says how many atoms are present in 3 moles of helium, He. So can you try to pause this video and solve this question? And once you are done solving, you can just resume back to playing the video and you can see my solution and mark yourself if you are right or wrong. So pause this video now and give it a try. So in order to solve this kind of question, we have that how many moles or how many atoms are present in what? 3 moles of helium. So the first thing to note, like I said earlier, you have to know that 1 mole of anything is equal to what? 6.02 times 10 raised to the power 23. So we can just write that down. So we have 1 mole of, so instead of writing anything, we know that we are working with helium in question. So we can write 1 mole of helium to be equal to what? 6.02 times 10 raised to the power 23. So now that we know this, the question is now asking us that how many atoms are present in 3 moles of helium. So we can now write that 3 moles of helium to be equal to unknown because we don't know the atom that is present in 3 moles of helium. So in order to solve this, as usual, we just have to cross multiply. And when we cross multiply, we have x multiplied by 1 to be equal to 3 multiplied by 6.02 times 10 raised to the power 23. So we can now have our x to be equal to 1.806 times 10 raised to the power 24. So if you multiply 3 multiplied by 6.02 times 10 raised to the power 23, you are going to get 1.806 times 10 raised to the power 24. So this is giving as our final answer to question of this type. And when you are doing a theory, you can just write that 3 moles of helium is equal to what? 1.806 times 10 raised to the power 24. So if you are doing a theory exam, writing this shows that you know what you are doing, because if you write that 3 moles of helium equals to 1.806 times 10 raised to the power 24, it shows that you simply understand everything you are doing. So you are not cramming in this question. So it is very simple to solve. So this is how to solve questions under the mole to Avogadro's relationship, and this will be all on the mole to Avogadro's relationship. So let's look at the third stoichiometry relationship, which is the mole to gas volume relationship. And moving to the third stoichiometry relationship, we have the mole to gas volume relationship. And under this mole to gas volume relationship, all you have to note is that at standard temperature and pressure, so at standard temperature and pressure, which is also known as STP, 1 mole of any gas is equal to 22.4 dm cube. So it can be equal to 22.4 dm cube or 22,400 cm cube. So it depends on whatever you are given in question, whether it is in dm cube or in cm cube. You can easily use any one of the two depending on your parameters. So let's look at examples under the stoichiometry of mole to gas volume relationship. And moving to the first example, the question as written on the board says that find the number of mole in 44.8 dm cube of O2 at STP. So one thing about solving stoichiometry question is just that you have to understand the question very well and write your expression clearly so you can know what you are doing in question. So in this kind of question, the question is asking us to find the number of mole in 44.8 dm cube of O2 at STP. So you can see we are having a dm cube, so we are going to use this dm cube and not cm cube. So in order to solve this, we know that 1 mole of any gas is equal to what? 22.4 dm cube. So we can just say 1 mole of, so instead of writing any gas, we can just put O2 because we are working with oxygen gas in this case. So we can say 1 mole of O2 is equal to what? 22.4 dm cube. So we just have to follow the same thing as we do in the Avogadro's relationship. So we can just follow the same step. So now that we know that 1 mole of O2 is equal to 22.4 dm cube, so we can now say that x mole of O2 is equal to what? 44.8 dm cube. Because why? The question is asking us to find the number of mole in 44.8 dm cube. So we don't know the number of mole, and that is why we put x mole here. So we can say x mole of O2 is equal to what? 44.8 dm cube because we don't know the mole that is equal to 44.8 dm cube. So the next thing to do is just to cross multiply. So when you cross multiply, you have x multiplied by 22.4 to be equal to what? 44.8 multiplied by 1. So we have our x to be equal to 44.8 divided by 22.4. So our x will be equal to 2 moles. So in order to understand what we are doing, you can say 2 moles of O2 is present in 44.8 dm cube at STP. So this shows that we know what we are doing. So when you are writing a theory exam, you can just write it this way and it will show that you know what you are doing. So this is how we solve question under mole to gas volume relationship. You can see it is very simple. You just have to know that 1 mole of any gas is equal to what? 22.4 dm cube or 22,400 cm cube. Depending on the parameters you are given, you are going to use any of the two. So once you know that 1 mole of any gas is equal to 22.4, you can just use what you are given in the question to solve the rest. And when you cross multiply, you get your final answer. And this is how to solve question under mole to gas volume relationship. So let's look at example on the mole to gas volume relationship. And moving to the second question as displayed on the screen, the question says, what volume will 2 mole of gas occupy at XTP? So in this kind of question, one thing you have to note is that you have to read your question very well so you can know what you are solving in particular. So this question is asking us that what volume, which means we are asked to calculate what? The volume. So what volume will 2 mole of gas occupy what at STP? So we know that 1 mole of any gas is what? 22.4 dm cube. So we can say 1 mole of, so instead of writing any gas, we are not giving the name of the gas here. So we can just put what you are asked to work with. So which is equal to 1 mole of gas to be equal to what? 22.4 dm cube. So we know that 1 mole of the gas is equal to what? 22.4 dm cube. Now, the question is asking us that what volume will 2 mole of gas occupy? So what volume will 2 mole? So we have been given the second mole, which is 2 mole of gas, to be equal to, we don't know the volume, which we denote as x. So we don't know the volume that it will occupy. So in order to get the volume, we just have to cross multiply as usual. So when we cross multiply, we have x multiplied by 1 is equal to 2 multiplied by 22.4 dm cube. So once we cross multiply, we have x to be equal to 44.8 dm cube. And this is our final answer to question of this type. So we can just say 2 mole of gas will occupy what? 44.8 dm cube of volume. So looking at the question that we have on the screen, option C is correct to this kind of question. So 44.8 is correct to this kind of question. So let's look at the last example on the mole to gas volume relationship. And moving to the last question as displayed on the screen, the question says, what volume will 0.5 mole of oxygen gas occupy at STP? So the question is asking us to calculate volume because the question says what volume. So we have to calculate the volume. So can you try to pause this video and solve this question? And when you are done solving it, you can resume back to playing this video. And once I solve it, you can check the solution to mark yourself if you are right or wrong. So pause this video now and give it a try. So in order to solve question of this type, we know that 1 mole of any gas. So instead of writing any gas, we are given what we are asked to work with in this question, which is oxygen. So we can just write 1 mole of oxygen gas is equal to 22.4 dm cube. So now that we know this, the question is now asking us that what volume will 0.5 mole of oxygen occupy? So we can just say 0.5 mole of oxygen gas will occupy what? Will be equal to x dm cube because we don't know the volume yet. So the question is asking us that what volume? So we are asked to calculate the volume. So we can cross multiply as usual. So once we cross multiply, we have x multiplied by 1 to be equal to 22.4 multiplied by 0.5. So we have our x to be equal to 11.2 dm cube. And this is given as our final answer to question of this type. 11.2 dm cube is correct to this kind of question. So we can just say 0.5 mole of oxygen will occupy what? 11.2 dm cube of volume. So option A is correct to this kind of question. And this will be all on the mole to gas volume relationship. So let's move to the next stoichiometry relationship, which is the mole to concentration or mole to solution relationship. And moving to the fourth stoichiometry relationship, we have the mole to concentration relationship. So one thing that we have to note here is that mole is equal to concentration times volume. So we have N equals to CV. So this is our formula for mole to concentration relationship, where N is the number of mole and C is the molarity in mole per dm cube. And we have the V, which is equal to the volume in dm cube. So this is all to note about the mole to concentration relationship. This has to do with what? Solution. So it has to do with solubility. So we have mole is equal to concentration multiplied by the volume. So N is equal to CV, and N is the number of mole, while C is the molarity in mole per dm cube, and we have the volume in dm cube. So let's look at examples under this mole to concentration relationship. And moving to the first example, under the mole to concentration relationship, the question says calculate the molarity of a solution containing 2 moles of NaOH, sodium hydroxide, in 1 dm cube of solution. So, like I said earlier, when you are calculating question on stoichiometry, you have to read the question very well so you can know what you are asked to calculate. So the question says calculate the molarity, which means what? You have to find the molarity in this question. And the molarity is what? Is the C. So remember that our formula is what? N equals to CV, and we have been given our N, which is the number of moles, to be equal to 2 moles. And also we have been given our volume, which is equal to 1 dm cube. So putting all this in our formula, we have the 2 moles to be equal to C, which is the molarity, multiplied by what? The volume, which is 1. So we have C to be equal to, when you divide this by 1, so you take C to be subject of the formula. So C is equal to 2 divided by 1. So our molarity will be equal to what? 2 mole per dm cube. So this is our final answer to question of this type. This is how we solve question under mole to concentration relationship. You can see it is very simple. All you just need to note is to know what you have to calculate in the question and how to use the formula properly. So let's look at another example still on the mole to concentration relationship. Moving to the second example, the question says how many moles are in 0.5 dm cube of 2 mole of HCl solution? So can you try to pause this video and solve this question? And once you are done solving, you can resume back to playing the video and check my solution if you are right or wrong. So in order to solve this kind of question, we know that we have been given our volume to be equal to 0.5 dm cube. And also we have been given our molarity, which is the concentration, to be equal to what? 2 mole. So we have to calculate how many moles. So the number of moles is equal to unknown. And we know that number of moles is equal to CV. So we can just input our parameter to this formula. So we have N to be equal to, what is our C? We have 2 multiplied by 0.5. And when you press this in your calculator, N will be equal to 1 mole. And this is the final answer to question of this type. So you can see 1 mole is correct. And this is how you solve question under the mole to concentration relationship. So you just have to know what the question is asking you to calculate in particular and how to use the formula properly. So let's move to the last example on mole to concentration relationship. And moving to the last example as displayed on the screen, the question says a solution containing 1 mole of NaCl in 0.5 dm cube of solution. What is the molarity? So again, can you try to pause this video and solve this question? And once you are done solving, you can resume back to playing this video and check my solution if you are correct or wrong. So this is a way you learn much more better and faster. So in order to solve this kind of question, we have to write our given parameter. So the question says a solution containing 1 mole. So we know that our number of mole is equal to 1, and also in 0.5 dm cube of solution. So our volume will be equal to 0.5 dm cube. So the question is now asking us to calculate the molarity. So what is the molarity? So our molarity, which is C, is equal to unknown. So we know that N is equal to CV. So inputting our parameters, we have 1 is equal to C multiplied by what? 0.5 dm cube. So making C the subject of the formula, we have C is equal to 1 divided by 0.5, and C is equal to 2 mole per dm cube. Or we can say C is equal to 2 molarity. So anyone you see in the option is correct. So 2 mole per dm cube or 2 molarity is correct to this kind of question. So option C is correct to this kind of question. So this will be all on the mole to concentration relationship. So let's look at our last subtopic, which is the mole ratio in chemical equation. And moving to the last subtopic, which is the mole ratio in a chemical equation. Let's say we have this chemical equation of reaction between hydrogen and water. So we have 2H2 plus O2 to give 2H2O. So in this kind of question, you can see we have 2H2 plus O2 to give what? 2H2O. So let's write out the molecules we are working with. So we have H2 ratio O2 ratio H2O. So this is the molecule we are trying to work with. So H2 reacts with O2 to give what? H2O. So the mole ratio in this case is what? 2 ratio 1 ratio 2. So how do we get 2 ratio 1 ratio 2? You can see we have 2 moles of hydrogen with what? 1 mole of O2 to give what? 2 mole of 2H2O. So we can say 2 mole of hydrogen, which is H2, react with 1 mole of oxygen gas, which is O2. Let me just put that here. To give what? To give 2 moles of H2O. So this is how to note the mole ratio in a chemical equation. You can see we have 2H2 plus O2 to give 2H2O. So we can say 2 mole of hydrogen gas react with 1 mole of H2, 1 mole of O2 to give what? 2 moles of H2O. So this is all you need to know about the mole ratio in a chemical equation. So in our next video, we'll be focusing more on this because this is used to calculate questions under stoichiometry. So in the second part of this stoichiometry video, we'll be looking more into details of how this mole relationship comes into question when you are calculating question under chemical equation in stoichiometry. And all this we have done so far is the basics of stoichiometry. So you have to note the basics. So in order to know how questions are being solved under stoichiometry, because once you understand the basics, no matter how they twist questions in stoichiometry, you'll be able to figure it out. So in our next video, we'll be looking at the second part of stoichiometry, where we'll be focusing on the mole ratio in chemical equation calculation. And also, we'll be looking at how questions are twisted under stoichiometry. So master these basics very well. So when we get to the second part, you won't have any problem solving any question under stoichiometry. So attempt this question on the screen and let me know your answer in the comments. And if this video helped you understand stoichiometry, don't forget to like this video, hit the subscribe button and turn on the notification bell so you won't miss any lesson from Tech and EduSpark Hub. And don't forget to share to more friends and comment the answer to the question below. And until next time, keep learning, keep coding, and I will see you in the next one.